Hello, my name is Jim Mullany from SciTech Process Solutions. Today is Tuesday, April 7th, 2020. I hope everyone's being safe. Today I'm doing a video source inspection on a customer's tool that, well, now it's a customer's tool and we ship it to them, but one that they purchased from us and we went through our remanufacturing process. It turns out we do not give our customers' names out on these videos because they're uploaded to our YouTube channel and shared with them, and we want to keep their privacy, but their PO number is 1333794 and they're located in Michigan. So this customer purchased a remanufactured ST-460. A 460 is a tabletop unit with the bottom roll-around cabinet. It has it can go up to 5-inch wafers. This customer running 4. It has the traditional two-step recipe: one rinse, one dry, which is typical on the older 260 type tools. For options, they have the DI resistivity, and let me look to make sure that's there. Squeeze back here. The DI resistivity measures the cleanliness of the DI water leaving the tool. That way, if you can put a specification on that it has to meet a certain cleanliness, or the tool alarms you and keeps running. Yep, I see the probe here. For reference, this is on the back of our rinser dryers. We put an ID tag, a pretty in-depth one. First of all, it's a small ID tag that talks about our support and service, our phone number and our URL. Then this one is remanufactured model ST-460. It's our serial number SRD-01247, remanufactured April 2020, and it gives the specs. And our part numbers, we started the company, we started at 0000. So we've done over 1,200, close to 1,250 rinser dryers. That's 1,250 spin rinse dryers. So we've done a lot of rinser dryers in SciTech's history. Okay, what I'll do is start this tool up, and then I'll go through talk about our remanufacturing process for them, and then some spare parts. This has a traditional, just a quick 30-second rinse, and because it's one dry, 250 seconds, and then I'll test the wafers, make sure they're dry. So you would load your wafers and hit start. There we go. So on a typical remanufacturing process, we follow this workflow. So we don't care what a system is purchased from us, what kind of model, what size, what version. We have the capabilities here of building all versions, all sizes. We can break down any tools and remanufacture to a different tool. It doesn't really matter to us. So this system happens to be an ST, which is the traditional system. It uses a brush motor, and I would call it an analog controller. Okay, ramp it up. Went through the harmonic right there. So now it ramps up to the high RPM, which is about 1,800. There we go. So on our remanufacturing process, what we do is we call the dry head build. So whatever the system is, we pull the parts, we build out in the dry build area up until where it can be powered on. When that's done, we have a second technician come over, do a quality control checklist, make sure that it's met all the quality standards. If it hasn't, for some reason, those are addressed and identified. When it does, it comes into final test more like this. This is just a head assembly without any poly. Then we put DI water to it, go through all the DI bugging because you can't tell in dry test if there's any water leaks with valves and so forth. We debug the tool in final test. Once it's done, and we have another quality control checklist that comes over and does the final inspection before it moves into poly. Then it goes into, so it probably has a good 25 runs thereabouts when it's in the wet processing area. Well, then it's configured into its poly. It's kind of important because spin rinse dryers are notorious for sounding good, but you put them in the poly and you have poly vibration, it makes noise. It's very hard to get some of that vibration out. Once it's in the poly, we run it for 50 process runs, make sure we debug all the valving, all the heaters, and so forth to make sure everything works great. Then it's passed over to sales for a video. We have about a minute and a half. Let me talk about our support service. On our website at scitechprocess.com, you can go and look on our left-hand side. We have a variety of buttons. We have all 3 versions of the rinser dryers, the S model, the F as in Frank, and the ST. The next 3 buttons are all the spare parts on those. And then we also have button number 7, which is our semi-tool SST, WST, etc. support. We also do a lot of other wet processing tools. We do quite a lot of mask cleaners. That would be the Ultra T, Ultra Tech, K&S, and so forth. We do the remanufacture of the HTC box washers. We do different metrology tools in final test. I won't spin the camera around, but I see 3 Nikon microscopes for inspection. I see an M gauge. I see an ambience thin film measurement system. Actually, that's a step height measurement system, I believe. We also do Rudolph nanometrics. We do KLA particle counters, etc. So you'll see a lot of different tools on our website. We're pretty diverse. Our core product line is the semi-total spin rinse dryers. We actually have, if you look over here, we're very busy in final test. Here's an 8-inch system that's being videoed today. Here's a system that's going to Canada. It's a double stack that's been upgraded to our state-of-the-art controllers with our new light sequencers. Here's 2 units that are going to Germany. This customer actually has 8 systems they're sending us, 2 at a time. We're upgrading them to our state-of-the-art controller, and then we're doing a full remanufacturing of their head assembly. Prior to that, they bought tools to start this whole process. So in total, there'll be about 10 systems we do at their site. We'll be the the sole supplier of all parts at that site. Okay, we have about, let's see, 55 seconds left. So right now what's happening is you have a hot end tube blowing in, you have centrifugal force, and you have bowl heaters. They're heating everything up. And so as the wafers dry, that's typical in a rinser dryer. Having that water there because the centrifugal force holds its center, you'll see it drop down when the RPMs drop down. At the end of the process, we have what's called a rotor stop positioner, RSP. It's backed by the motor. It actually has a piston that shoots out with a rolling ball on it. It rolls against the back cam, finds the flat and upright, so we call home position, which is 12 o'clock. Otherwise, when you open up your machine, the wafers can be upside down, they'd fall on the ground. So that holds it in place too, so the rotor can't move. I'll show you that in a second. We have 10 seconds left. At the end of the process, it'll start spinning down, and then I'll hear the door release when it gets to 12 o'clock, and I'll be able to open it up. It turns out on the traditional ST units, the newer models go by RPM, and when they hit the 70 or lower, that's when the RSP fires. On the 228 and 328 controllers, it's a time sequence inside there. You can't change that. Okay, open to 12 o'clock. I heard the door release. Let's start off feeling hot end suit. Feels good. 4-inch wafers. Let's take them out. Nice and warm, nice and dry. Looks good. Get those back in there. So this system is ready to go. We'll go ahead and upload this video to our website, send our customer a link, and they'll be able to do a source inspection at their site and be able to tell us it's okay to package up and ship. Again, my name is Jim Mullany from SciTech Process Solutions. Today is Tuesday, April 7th. If you need to contact us, please call us at 916-797-9000 and ask for anyone in our sales organization. Thank you.